motors would be a little bit different. Also on our gas furnaces, the S9X, X1s, X2s, XBs, or the S8X 1s, 2s, and Bs, they're all going to be using the constant torque motors. Pretty much anything that's not using a variable speed motor is going to be using a constant torque motor now. Simply put, it's kind of the new standard. We're going to go over some setup and configuration. How do we set these fan speeds? How do we adjust these fan speeds? How do we make changes? And what are we looking for? On our gas furnaces, it's a little bit, probably the most difficult part. To adjust the fan speed, it's done through the display, the little 7-segment display on the main circuit board, the IFC, using the menu and options button. I like to look at it this way. The menu button is what scrolls down, and the option button is what scrolls right. There's no scrolling up, there's no scrolling left. It's either down until you get to the bottom, which case it recycles back to the top. And you scroll to the right, and if you skip what you wanted to click, you keep on scrolling right, it'll reset back to the front and keep going to the right again. So the easiest thing to do in this case is you're looking for only 2 of the options down here. We're going to skip over constant fan because continuous fan, so your fan only call on these constant torque motors is set for the speed tap 1. It is not adjustable at this time. That is a big thing of contention that a lot of customers and homeowners don't really appreciate. Sometimes they want a higher fan speed, but on continuous fan on these constant torque motors, your only option is speed tap 1. But if we are adjusting our fan speed for our heating or for our air conditioning, our compressor fan speed, it's a little bit, we have a lot of options. So as you can see here, we started up here at idle, and you scroll all the way down until it gets down to the COP or the HTP. And up close, it looks like this. When you get down to the COP, this is setting your compressor speed tap. So this could be for a heat pump, or it could be for just an AC. Either way, you're going to be setting one fan speed tap for either one, for both of them. In this option here, this is showing what it looks like on a 2-stage option for both the compressor or the heating. If you tell it it's only got a single-stage AC, and if it's a single-stage furnace, you're only going to have one option. You won't have the 2 lines. But in essence, what you're going to do is you're going to scroll down, hit the menu button until you get down to COP. Once you are there, you're going to hit the option button and scroll over to the fan speed tap that you choose. The very first time you hit option, it's going to show you the current setting for your fan speed tap. So if it's currently set at what you want, or if you just want to see what it's at, you scroll down, hit the menu button until you get to your option, the COP or the HTP for cooling or heating speed tap. Press the option button 1 time, and that'll show you your current setting. That might be a great way to start, because once you know your setting, you can now check your static pressure and see what your fan is actually going to be running at. But this is what it looks like. You have options, as you can see here, of 1 through 9, depending on what you have it set up for. So we have 9 speed taps. On the S8X, it's very similar. As you can see here, we only have a single stage AC instead of for a single stage heating, and the bars down there only have 1 row, so you only have 1 speed to set. If you have 2 stage though, you go through, you set the first stage. Once you set that, it kicks you into the second stage, and as you can see, it says on the cooling, it says C1-123, C2 4, 5, 6, 7, 8, 9. That's saying cooling stage 1 and cooling stage 2. The same is set there for heating stage 1, heating stage 2. It'll say H1 and then your speed tap. It'll say H2 and then your speed tap. So you know which one you're setting. When you are setting your speed taps, this is on the S9 X models. Like I said, you have 9 speed taps. Your actual CFM will be completely dependent on what your static pressure is. If you're static, so you must take a static pressure reading once you have it running at your speed tap. That's why I would recommend you first see what your speed tap is set for, turn it on at that speed tap, and then check your static pressure. That way you know where you're at. This example here, I'm going to show you 3 different units here. First one is a 60,000 BTU gas furnace with a 4-ton blower. As you can see, at a speed tap 5 in the middle there, at a low static at 0.1, you'd be moving close to 1300 CFM. On that same exact speed tap, if you have a high static pressure of 0.9, you're only moving about 1000 CFM. So you're going to lose 300 CFM depending on what your static pressure is. And so that's almost a ton of air you can lose based off static pressure. So it's very important that you're getting a accurate static pressure reading, so that way we can know how much CFM we're moving, so we can move the appropriate CFM for your outdoor unit. This would be an 80%, the S8X2 60,000 with a 4-ton. And if you'll notice, we have different speed taps here. Some of this is going to be different. We have a different heat exchanger, so we have different resistance across for the fan to blow through. This changes. So here, a speed tap 5, this is still a 4-ton blower. It's actually the same motor. You'll notice that we have different CFM. So here at speed tap 5 at 0.1 static, you're at 1362. We move up almost 70 CFM. And at a high 9.9 static, we're at 946, so over 50 CFM slower. We have 50 CFM slower on the low and on the high static, and almost 70 CFM higher on the low static. So not just because it's a 4-ton blower doesn't mean you're going to have the exact same CFM. So it is important that you are checking your service facts and checking actually what your static pressure is. Here would be an example of the air handler, the GAM5, also a constant torque motor, but we don't have 9, we only have 5 speed taps. It is done a little bit differently. We're not going through the 7-segment display. You literally have to move a wire from post to post like you did on the old PSC motors. But here, this is the GAM5 with a 3-ton GAM5. If you look here, speed tap 1, 2, 3, 4, and 5 is going to change depending on your voltage. So it is important, not only do we know our static pressure, know our speed tap, but on the air handlers, you also have to know your voltage, because you could have a 208 or a 230, 240, and that's going to change your CFM. So please, when you're setting these up, take the time to make sure you verify your voltage, verify what speed tap it's currently on, turn it on and check your static pressure, and then compare that to the chart and the service facts, and that's going to give you your CFM. If you don't take the time and do all these things, it's just a guessing game, and that doesn't help anybody out. It doesn't help you out. It doesn't help the homeowner out. It only causes callbacks, and I know nobody wants those. As you can see here on this 3-ton GAM5, you're based off your static pressure. If you're at a 0.1 on speed tap 5, 1400 CFM. The same static pressure. So on a speed tap 1, you can drop as low as 500 CFM. In this case, the constant fan always comes on speed tap 1. And as you can see, the little cross on speed tap 4, that is where your the factory setting for your fan comes set is on tap 4. So if you're not looking for 1200 CFM, which is kind of in the middle there of your static pressures, this may not be the speed tap you want. If you have very large ductwork, you may be running too much air. Or if you have very small ductwork and it's undersized, we might be running down into the, only 2 tons of air, 889 CFM if you have high static pressure. So it is important that you are paying attention and checking your static pressure. When we say check your static pressure, what we want is your total static pressure, which is across the blower pretty much. I want to check on the furnace before the coil and without the filter in. So you're kind of between the filter and the furnace and between the coil and the furnace on a gas furnace. We just want the static pressure across the blower. This can be done by turn the power off and removing the high temperature limit, which is inserted into the heat exchanger. Put your magnehelic in that hole and seal it up with some tape, and then check your static pressure reading there. That'll give you your supply side before the coil, but after the blower. And you can do it if your filter is mounted right to the furnace. You could remove the filter and put your pressure sensor right there in the door for the filter and seal up around it and check your return static there. Alternatively, if you needed to, you could drill a small hole on the side of the furnace, opposite side of the filter in this application, and check it right there as well. But when we're checking our total static, we do not want to include the filter. We do not want to include the coil. So I know that can be difficult at times, but there are ways around it. In your certain specific application, if you're not sure how to do that, you can call tech services, and we are more than happy to help you find a location that would be the most accurate for that situation if you're not sure. Testing. These motors are actually quite easy to test, and you can verify if you're having a problem with the motor or the board, if the board's not supplying the proper voltage, or if there is and the motor is the problem. I'll show you quickly and easily how to identify which one it is. On your gas furnaces, this is the S9X or even the S8X, you're going to have a 6-wire plug on the board. It'll be labeled with all the speed taps on there, and it'll say common 1, 2, tap 1, 2, 3, 4, and 5. 6-pin motor connector, really easy to identify. This is going to provide our control voltage to tell it what speed to turn on. Your high voltage will still be off of the main line and neutral power wires. On the motor itself, on the S9X models, they're going to have a plug that looks like this. You're going to have your high voltage there on line and neutral, and then you're going to have your 5 speed taps and the common. If you were checking it at the motor itself, as an example, if you're checking your high voltage, the top diagram there, line and neutral, you check your 120 volts on the gas furnace. Checking your low voltage, or checking volts DC, which is the control voltage going to these, and you can measure it from common to any of the 5 plugs, and that'll tell you which one is getting DC voltage. On the S8X, we're testing the same stuff, but the plugs look a little bit different on this motor. As you can see, it's 2 plugs, not 1. We have the 6-pin low voltage control connection and a 3-pin high voltage connection. Makes it a little bit simpler and easier to identify. But as you can see there, from line to neutral, 120 volts, because this is the gas furnace. The G stands for ground. And then you're going to have your common and your 1, 2, 3, 4, 5 pin connector on the motor on the other plug. So both of them are going to have the same voltage readings we're looking for if you are checking if it is getting voltage off the board to make sure the motor is running. You're going to check from common, and you can check at the board with it plugged in. Stick your needle leads into the back of that plug, and you are looking for DC voltage. If we are running on speed tap 1, you're going to have 8 volts DC on tap 1. Pretty simple. That's going to be speed 1. Tap 2 is another 8 volts DC on tap 2. Tap 3 is 18 volts on tap 3. 4 is so on and so forth. The thing where people get confused or get complicated is once we hit the speed tap 6, 7, 8, and 9, the higher speeds, you're getting voltage on 2 separate taps. For an example, tap 8 would be tap 1 and tap 2 would both have the 8 volts DC. If we're going speed 7, you're going to have on tap 1 8 volts DC, and tap 3 will be 18 volts DC. Obviously, if you keep on going down there, speed 8 is 1 and 4, and speed 9 is 1 and 5. The volts DC going on each of those wires doesn't change whether you're in just one of them or if you have 2 of them calling. So like I said, so tap 3 would be 18 volts, and if you're calling tap 7, tap 3 is still 18 volts for the 2 wires. That is how you can tell if we have voltage coming off the board or not, the proper voltage. Simply though, if we want to test the motor itself, we think we have a bad board, but we want to make sure the motor is still good. Simply put, you unplug that wire harness, kill the power, unplug the wire harness from the board, and you're going to apply 24 volts from common to any of the 6 pins, or any of the other 5 pins, sorry. So you're going to hook up common wire from your board to the blue wire marked common on the plug, and then you're going to hook up 24 volts AC to any of the 5 speed taps, 1, 2, 3, 4, or 5. That's going to give you that speed to turn on and have the motor run at that speed. If you're only having the motor work on certain speeds and it doesn't work on others, you can try this. You can force 24 volts to that speed tap that won't run when you have it set that way. And you can see if the motor will work. If the motor does not work when you run 24 volts to it, and you still have 120 volts AC to the high voltage, that would be a bad motor. If the motor works on all the speed taps, all 5 speed taps, but it doesn't work when you have the board, when it's plugged in the board, that would be a sign of a bad board. On a GAM5, the voltage is a little bit, the wiring's a little bit different. Like I said, we're not coming off a board with a GAM5. The wires will go straight from each of your controls. So like the G wire for constant fan comes in on the green wire, and it goes straight to the motor. And so where your green wire lands on tap 1, 2, 3, 4, or 5 would be your constant fan. Here we're going to still have marked the high voltage marked line in neutral, L and N, although it's 240 volts now. And so you're going to have 120 volts going to each of those legs. Verify between L and N that you still have your 240 or 208 at the motor itself. If you do, go ahead and you can apply 24 volts to tap 1, 2, 3, 4, or 5, and that will bring on your blower motor. If it does not, we have a bad blower motor. If it does, that means we're losing that voltage somewhere between the blower motor and the signal to come in from the thermostat. So testing the motors is quite simple. You can just use 24 volts off your board, apply it to any of the speed taps, and it should run as long as you have your high voltage still active on the board. That's it. This is a really simple class. These things are very simple. Does anyone have any questions at all? Okay. If nobody has any questions, I won't hold you any longer. I appreciate you guys being here. It's a pretty simple setup. These things are very easy to go through everything. Everything is accessible from the board or from the wire harness. You might need needle leads to get in there and test them, but they're pretty straightforward motors. The hardest part people do is they forget to check their static pressure, and they just set a fan speed tap. So if you just set your fan speed tap and don't check your static pressure, you're not going to know how much air you're moving. It is really highly critical that we're checking our static pressure on these constant torque motors, because they don't know the static pressure. They can't sense it. And so everything comes back to, we have to check your static pressure after you set your fan speed. Once you do make an adjustment to your fan speed, maybe your CFM was too low or too high, check your static pressure again. So it's set and test. If you reset the speed, you have to retest your static pressure to make sure you verify your airflow. All right. Thank you, everybody, for coming. I hope you have a great rest of your day and have a great morning. Thank you.